Hey guys, welcome to this session by Intellipaat. Now you guys must have come across the term R programming quite a few times and numerous questions would have popped into your head. So is it just another programming language? How is it different from other programming languages? And is it really hard to learn R programming? So today we've come up with just the right video so that you can start your journey in the field of R programming. So let's have a quick glance at the agenda. We'll start off by understanding what exactly is R programming, and then we'll work with variables in R. After that, we'll look at the different types of operators, and then we'll learn about objects in R, following which we'll implement flow control statements. So what is R? Well, R is a language which was developed by statisticians for statisticians. So if you want to perform any sort of statistical analysis, then R should be a go-to language. Now, R is also a great visualization tool. So R provides packages such as ggplot2 and plotly to create stunning visualizations. And R is an open source cross-platform comparable software, and it's just plug and play. So all you have to do is install R once and then you can start having fun with it. And since R is an open source software, you can actually modify the code and add your own innovations to it. And being cross-platform compatible, you can run the same R code on multiple operating systems. And the best thing about R is, it is a Turing complete language. That is, it can perform any task which a Turing machine can. Now that is amazing, isn't it? So this is what makes R such a powerful language. So you can do multiple operations with R, such as statistical analysis, implement machine learning algorithms, and also create stunning visualizations, all with this super language called as R. So now that we know what exactly is R, let's go ahead and install R and R Studio in our systems. So we can install R from the site over here. So we can go to cran.rproject.org. Right, so we have different versions of R. So if you are using a Linux system, then you can download R for Linux. If you're using a Mac system, then you can download R for Mac. Similarly, if you're using a Windows system, you can download R for Windows. And since I'm using a Windows system, I'll click on this link. Right, so you see this link over here, install R for the first time, click over here. Now this is the latest version of R 3.5.1. So you have to click on it and then the download would start. Now, since I've already downloaded R in my system, I'll go ahead and cancel this. Right. Now, after you install R, you would also require an IDE so that you can perform your tasks quite easily. So one such IDE is RStudio. So RStudio is a free open source software which provides a smooth interface so that you can perform all of your operations quite easily. And you can download RStudio from this site over here, rstudio.com. So let's go to rstudio.com and download RStudio. Right, so we have entered the site. I'll click over here, download RStudio. And we see the free version over here, RStudio Desktop Open Source License. Again, I'll click on download and you see different versions of R. So again, if you're using a Windows system, this is the right link for you. If you're using a Mac system, you can download RStudio for Mac. Similarly, if you're using a Ubuntu or a Fedora system, you can download these versions. And again, since I'm using a Windows system, I'll click on this link. Right, the download has again started. And since again, I already have RStudio installed on my system, I will cancel this. Right, so we have successfully installed R and RStudio in our systems. Now, let's go ahead and understand what exactly is a variable. So simply put, a variable is a temporary storage space. So let's understand the concept of variable with this example over here. So let's say we have this cart and this cart would be our temporary storage space. Now I also have an apple with me and I decide to store this apple inside this cart on a temporary basis. Now after some time, I decide to remove that apple and replace it with a banana. Now again after some time, I decide to replace that banana with a mango. So this is the basic premise behind a variable. It provides a temporary storage space where we can keep on changing the values. Right. So now that we've understood what exactly is a variable, let's head on to RStudio and implement some variables. Right guys, so this is how RStudio looks like. So we have 4 panes in total. This is the script window. This is the console window. This is the environment pane, and this is the tab where we can install new packages and also build some plots. Right. So what I'll do is I will create a new variable and name that variable to be fruit. and I will assign it a value of mango. Now I will select this and paste it inside the console window. Now let me print fruit. So I get the result mango over here. And since fruit is actually a variable, I can change the value which is present inside it. So again I will type in fruit, and this time I will assign a value of apple. So I will paste it in the console window. Now let me print fruit. So see that the initial value of mango has been replaced with apple. Similarly, I'll create the same variable and I'll change the value. So this time the value which I'm assigning this would be a banana. Let me paste it over here. Now let me type in fruit, let me print it. So we get a banana. So this is how a variable works, guys. So this is a temporary storage space where the values can be kept changing again and again. So what I've basically done over here is I have taken a variable fruit. Initially I had assigned a value mango, after which I had replaced that value with an apple, and again I had replaced the same value in the same object with banana. Right. So now that we've understood what exactly is a variable, so each variable is basically associated with a data type. So let's start off with the first data type, numeric. So a variable can store numeric values such as 5, 1000 and -33. So after numeric data types, we have the character data types. So a variable can also have character values such as these. So a character value could be either a single character Z, or it could be the word Sparta, or it could be two words such as hello world. Right. Now after the character data type, we also have the logical data types. So a variable can store logical values such as true or false. Now you guys need to keep in mind that in R, by convention, this needs to be in capital, right? So this keyword true is capital and this keyword false is also capital. And then we have the final data type, which is complex. So a complex data type basically comprises of two parts. First is the real part, and then we have the imaginary part over here. So 2 plus 5i, 30 minus 30i, and minus 100.47i, all of these are complex data types. So similarly, a variable can also have complex data types. Alright, so now that we've understood what exactly are data types, let's go to RStudio and implement some variables with different data types. So I'll start off by creating a variable which would have a numeric value. So I will name this as my obj, and first I will assign it a numeric value which is 123. Now I can use the class function to have a look at the class of the object. So let me type in class, and inside this class function I will pass in the object which I've just created, which would be my obj. Right. So the class of this object is numeric. Now what I'll do is, to the same object I will pass in a character value. So let's say I will pass in the word Sparta to this. Let me hit enter. Now let me have a glance at the class of this object. Class of my obj. So now we see that the class of this object is character, right? So initially the class of this variable was numeric, but then when I had assigned a character value to the same variable, the class changed to character. Now I'll go ahead and assign a logical value to this. So let's say I assign a true value to this. Now again let me have a glance at the class. So class of my obj. So this time this is of logical type, right? Now finally let me assign a complex type to this. So my obj, and using this assignment operator, let's say I would give this a value of 30 plus 100i. Right, now let me use the class function and have a look at the class of this object. So that would be my obj. Right, so the class of this object is complex. So what we basically understand from this is, as we change the type of the value given to the object, the class of the object also changed. So we started off by assigning a numeric value to the object. Then when we saw the class of that object was numeric, then we had changed the value and we had assigned the same object a character type, and that's class change to character, right? So this basically means that if we change the value given to the variable, the class of that variable would also change, right? So these were data types in R. Now let's have a look at the different operators which are available in R. So these operators basically help us to perform some sort of mathematical or logical operations on top of our variables. So basically we have these four operators in general. So we can have assignment operators, arithmetic operators, relational operators, and logical operators. So let's start off with the assignment operators. So as you can see what is stated over here, assignment operators are basically used to assign a value to an object. And these are the three different assignment operators available in R. So we can just use the equal to operator to assign a value, or we have this another symbol over here. So here we have a less than operator, after which we give a hyphen. So this is another type of assignment operator. Here again we have the hyphen followed by a greater than symbol. This is another type of assignment operator. And if you have a look at this, we have some examples over here. So what we are doing is we are assigning the value of 10 to this variable x using this assignment operator. Similarly here, we are assigning this value 20 to this variable y using this assignment operator. And similarly, we are assigning this value of 30 to this variable z using this assignment operator. So again, let's head to our studio and we will be implementing some assignment operators and assigning some values to some objects. So let's say I create the same variable x. So I will put in the variable name which is x, after which I will give in the assignment operator which is equal to, and I will give in the value now. So let's say the value which I want to give this is 10, right? Now similarly, I will assign a value to the variable y. So I will give in the name of the variable which is y. Then I will use another variation of the assignment operator. So first I will give in the less than operator, and then I will give in a hyphen. And the value which I give is, let's say 20. So I'm basically assigning the value 20 to this variable y. And then I will give the value 30, and I am assigning this value 30 to the variable z. So this is basically inverse assignment. So first I give in the value, and after giving in the value, I would assign it to the variable, right? Now let me print x, y, and z values. So x, y, and z. So we have successfully assigned the value of 10 to variable x, we have assigned 20 to variable y, and we have also assigned 30 to variable z. Right, so that is how we could work with assignment operators in R. Now let's head on to arithmetic operators. So these arithmetic operators are used to perform basic mathematical operations. And these are the different arithmetic operators which we have in R. So this plus symbol over here helps us to add two variables. Then we have this minus symbol which helps us to subtract two variables. Then we have this asterisk symbol which helps us to multiply two variables. And finally we have this forward slash which stands for division. So with the help of this we can divide two variables or two operands. Right, now we are back to our studio and let's perform all of these arithmetic operations. So I'll start with addition first. So we had just seen that we had created three new variables x, y, and z. So we will be performing all of those arithmetic operations on these three variables x, y, and z. So I'll start off by adding these two variables. So x, which is the first operand, then I will give in the operator which is plus. After which I will give in the second operand which is y, and we get the result which is 30. So the initial value of x was 10 and the initial value of y was 20. When we add 10 plus 20, we get the value to be 30. Right. Now, similarly, let me perform another addition operation. So this time, let me add y plus z. So the initial value of y was 20 and the initial value of z was 30. And when I add these two, I get a value of 50. So these were some addition operations. Now, let me perform some subtraction operations. So I want to subtract y from z. So I will give in the first operand which is z. And I will give in the operator which is minus, and then I will give in the second operand which is y. So I am subtracting y from z, and this is what we get. So z is 30 and y is 20, and when I subtract 20 from 30, I get 10. Now let me subtract x from z and let's see what do we get. So this time what I'm doing is, so the z value is 30 and x value is 10. And 30 minus 10 gives us a value of 20, right? So these were some subtraction operations. After which we'll start with the multiplication operations. So let me multiply x with y, and let me see what do we get. So x value is 20. So x value is 10 and y value is 20. And when we multiply 10 with 20, we got a value of 200. Right. Now similarly, let me multiply y with z. So y asterisk z. Let me hit enter. So we get a value of 600 because y's value is 20 and z's value is 30. And 20 cross 30 gives us a value of 600. So these were some multiplication operations. Now let's head on to division operations. Right. So let me divide z with y and let's see what do we get. So z's value is 30, y's value is 20, and 30 by 20 gives us 1.5. Now let me do y with respect to x. So this would be 20 divided by 10, and this would give me a value of 2. Right, so these were some arithmetic operators. Now let's look at relational operators. So these relational operators are used to compare two operands. So these are all of the different relational operators which we have. So this is the less than operator, and this helps us to find out if the first variable is less than the second variable. Then we have the less than equal to operator. So this helps us to find out if the first operand's value is less than the second operand's value. Then we have the greater than operator. And this helps us to find out if the first operand's value is greater than the second operand's value. And then we have the greater than or equal to operator. And this helps us to find out if the first operand's value is greater than or equal to the second operand's value. And then we have the is equal to operator. So here we just given two equal to's. And this helps us to find out if the values of both the operands are equal. And thus finally we have the not equal to operator. So first we given the exclamation mark and then we given the equal to symbol. So this helps us to find out if the first variable is not equal to the second variable. Again, let's head back to our studio and let's implement some relational operations. So let me check if the value of x is less than the value of y. So I get a true value because 10 is less than 20. Now let me check if x is less than or equal to y. Now this again is true because 10 is less than or equal to y. Now I will go ahead and check if x is greater than y. So this time I actually get a false. So this is because 10 is not greater than 20. Right. Now similarly, let me check if x is greater than or equal to y. This again is false because 10 is neither equal to nor greater than y. Now, let me go ahead and check if the value of x is actually equal to the value of y. So this time again, I get a false value because 10 is obviously not equal to 20. Now, let me check if x is not equal to y. So this would obviously be true because 10 is obviously not equal to 20. So these were some of the relational operators. And then we have the logical operators. So the logical operators are basically used to make a decision on the basis of a condition. And the two most majorly used logical operators are the AND operator and the OR operator. So this is the AND operator. So let's have a look at this table to understand how does the AND operator work. So we have two conditions over here. And if both of those conditions are evaluated to true, only then the AND operator would give a true result. So let's take this case over here. So here, the first condition is evaluated to false and the second condition is also evaluated to false. And that is why the result which we get is false. Let's take the second case. So over here, the first condition is evaluated to false. The second condition is evaluated to true. But since both of the conditions are not evaluated to true, the final result is false. Again, let's have a look at this third case. Here, the first condition is evaluated to true, but the second condition is false. And that is why the final result is false. So let's take this final case. So over here, this is the only case where both of the conditions have been evaluated to true. That is, the first condition is also true and the second condition is also true. And that is why the final result which we get is true. Then we have the OR operator. So the OR operator gives us a true result when either of the conditions is true. So let's take the first case here. The first condition is evaluated to false. The second condition is also evaluated to false. And since both of the conditions are evaluated to false, the final result is false. Then we have the second case over here. Here, the first condition is false and the second condition is evaluated to true. And since the second condition is evaluated to true, the final result is true. Then we have this third case. Here, the first condition is evaluated to true, but the second condition is evaluated to false. But since at least one of the conditions is true, the final result is true. And thus obviously we get a true result because both of the conditions are resulting true. Now let's go to RStudio and implement these logical operators. Right. So let me give the first condition. So the first condition would be x is less than y. Then I will give in the AND operator and I will put in the second condition. So the second condition would be x is less than or equal to y. Now let's examine this command properly. So x is less than y. This means that 10 is less than 20, which is true. Now let's examine the second condition. So over here, 10 is less than or equal to 20. This again is true. So true and true would give us a true result, right? Now let me change the conditions. So let me give the first condition to be x is greater than y. I will give in the AND operator. Now let me put in the second condition. So the second condition would be, let's say x is not equal to y. So here x is greater than y would be yielded to false because 20 is not greater, because 10 is not greater than 20. Then let's examine the second condition. This would be evaluated to true. So 10 is obviously not equal to 20, but the final result is false because one of the conditions is evaluating to false. So this was the AND operator. Now let's work with the OR operator. So again, let me give in the first condition. So the first condition would be x is not equal to y. Now let me use the OR operator and let me give in the second condition. So the second condition is, let's say x is greater than y. So guys, what do you think would be the result over here? So we get a true value. This is because the first condition yields a true value. So 10 is obviously not equal to 20. But even though the second condition is yielding false, since we have at least one condition which is yielding true, the final result is also true. Now let me do a variation over here. Now let me give in two false conditions and let me see what will happen. So the first condition would be x is greater than y. Then I'll give in the OR operator and then I'll give in the second condition. So let's say the second condition is x is equal to y. So this time we get a false value. This is because first condition is false. The second condition is also false. And when we use OR operator with two false conditions, the final result is obviously false. Right, so these were some of the operators in R. Now let's go ahead and understand objects. So basically every data element in R is an object. As simple as that, guys. I'm reiterating it. Every single data element is basically an object in R. And these are the 6 most basic used objects in R. So we have a vector, matrix, factor, list, array, and a data frame. So let's start off with the most basic object, which is a vector. So a vector is actually a linear object which contains elements of same type. So elements of same type, or in other words, elements which are homogeneous. And this is the syntax to implement a vector in R. So you will be using the C function or the combine function and you will be passing in all of the elements. Right? So over here, I am using the C function to pass in 3 elements, which are the numbers 1, 2, and 3. And similarly over here, I am creating another vector where I am passing in 2 elements, which are true and false. So let's go to RStudio and create some vectors. Right. So I will create a vector and I'll name that vector to be my vector. Now using the assignment operator, let me assign some values to this. So I'll be giving only the elements of same type. So let's say I will give in elements of only numeric type this time. 1, 2, and 3. So this vector comprises of 3 elements and all of those 3 elements are of numeric type. So let me have a glance at the class of this. So class of my vector. So we see that this is of numeric. Now what I'll do is to the same my vector object, I will assign elements of different type. So this time I will be passing in elements of character type. So let's say the first element is character A, the second element is character B, and the third element is character C. Let me hit enter. Now let me have a look at the class of this. So class of my vector. So see that this time it is a character. Now again to the same object, which is my vector, let me assign logical values. So the logical values would be true, false, and true. Now let me check the class. So that would be class of my vector, and this is logical. So you see that the class of the vector is basically determined by the elements which are passed to it, and all of the elements are basically homogeneous. Now what I'll do is I'll actually pass in elements of two different types to the same vector, and let's see what would be the result. So the name of the vector is my vector. I will use in the C function or the combine function, and this time what I'll do is I will pass in two numeric elements first, and after passing in two numeric elements, I will pass in two logical elements, true, false. So this is a vector which comprises elements of different types. So the first type is numeric and the second type is logical. So guys, what do you think would be the result? So do you think there would be an error or we would be getting some other result? So let's see what we'll actually get. So let me print in my vector over here. So this is quite a strange result, isn't it? So we had actually passed in 1, 2, true and false, but the result which we are getting is 1, 2, 1 and 0. This is because the logical values have been coerced to numerical values. So this means that a vector can have only homogeneous values. So the value of 1 and 2 are the same. So 1 is a numeric value, it remains as 1. 2 is a numeric value, it remains as 2. But this true logical value over here, this has been coerced to a numeric value of 1. Similarly, we have this false logical value over here, and this has been coerced to a numeric value of 0. Right. So this time I will pass in character values and logical values to the same vector. Let me name that vector to be my vector. And let me use the C function to assign some values. Right. So let's say the first two elements are characters. So the first element is the character A and the next element is the character B. After this, I will give in two logical values. Again, there would be true and false. Now guys, what do you think would be the result for this? So let me just check. So that would be my vector. Right. So this time, the logical values have been coerced to character values. So A and B were initially character and they remain as character. But these two values which were actually logical, their values have been coerced to character. So just to verify it, let me show you the class of this character. So class of my vector, this is a character. So even though I had passed in two character elements and two logical elements, the class of both of the logical elements has been changed to character, and the class of the entire vector is also character. Right. Now finally I will pass in all of the elements of the three different types. So I will pass in two numeric values, two character values and two logical values. So I will pass in two numeric values which are 1 and 2. After this I will pass in two character values which are A and B. And then I will finally pass in two logical values which are true and false. Now let me hit enter my vector. So this time all of the values have been coerced to character. So this means that character data type has the highest precedence, the numeric values has the next highest precedence, and the Boolean values or the logical values would have the lowest precedence. Right? So again, just to verify, let me show you the class. So that would be class of my vector. So this is a character. So even though we had passed in elements of three different types, the class has been changed to character. So let me print in my vector again over here. So these are the 6 different elements which are present in this vector. So now I'll go ahead and show you guys how to extract individual elements from this character. So let's say I'd want to extract this 4th element from this vector. So let's go ahead and do that. So for that, I would have to give in the name of the vector first, which would be my vector. After that, I will give in 2 square braces. And inside that square braces, I will give in the index number. So the index number is 4 over here. So the numbering starts from 1, guys, right? So this is index number 1, 2, 3, 4, 5, 6. And since I want this element over here, the index number would be 4. Right. So this is how we can extract the element B from this vector. Similarly, if I wanted to extract this 6th element over here, all I have to do is, given the name of the vector, which would be my vector, I will give in 2 square braces, and inside that I will give in the index number, which would be 6. Right, so we have extracted this false value. Now let's say we wanted to extract only the alternate values or the alternate indexes from this vector, that is the first, third and the fifth values from this entire vector. So for that, I would have to give in the name of the vector, then I'll give in 2 square braces, and using the C function or the combine function, I'll be selecting the first, the third and the fifth index, right? So from this entire vector, I have extracted the first element, the third element and the fifth element. Now similarly, if I wanted to extract all of the elements starting from index number 2 to index number 5, this is how we can do it. So I will type in my vector over here. I will give in square braces. I will put in the first index number, which is 2, and then I will put in a colon, and then I will give in the last index number, which is 5. So like this, we can extract all of the elements starting from one particular index to the last index. So let me hit enter. So we have extracted all the elements starting from index number 2 to index number 5. So that is how we can work with vectors. So next we have lists. So list is actually similar to a vector, but the only difference is a list can contain heterogeneous elements. That is, even though if you pass in elements of different types to the same list, they will be not coerced to the data type of higher precedence. So let's take this example over here. So this is how you can create a list. So first you will use in the list function, and then you will give in the individual elements. Now we see that one element is of numeric type and the other element is of character type. Now even though this is of numeric, this will definitely not be coerced to character type. So this is the speciality of a list. So you can pass in heterogeneous elements where the heterogeneous elements will not lose their core identity. Right, so let me create the first list and name that list to be my list 1. And I'll use the assignment operator again. I will use the list function. Right, now using the list function, what I'll do is I'll pass in 3 different elements. So the first element would be a numeric value 1. The next element would be a character value A. And the third element would be a logical value true. Let me hit enter. Now let me print out the list. So let me show you guys how does a list look like. So my list 1. So guys, this is how a list looks like. So see that there are 3 different components over here. There's the first component, second component and the third component, right? So this first component contains the numeric value 1. The second component contains this character element A, and this third component contains this logical element true. Now let me show you guys the class of each of these individual elements. So let me show you how to extract individual elements first. So my list 1. Now let's say I would want to extract the second component. So if I want to extract the second component from the list, I will give in square braces. Now inside the square braces, I will give in another set of square braces. Now inside this, I will give in the component number. And since I want the second component over here, I will put in 2. So this is how we can extract the second component from this entire list. Now let me have a glance at the class of this. So class of, I'll give in the name of the list, which is my list 1. I'll put in 2 braces. Inside the braces, I'll give in another set of braces. And let me give in the component number, which is 2. So you see that this is of type character. Now similarly, let me check the class of this component over here. So the component would be 3. So the class is logical. Now let me check the class of this first component over here, which is 1. So numeric. So you see that even though we are assigning elements of different type, these elements are holding on to their true classes or to their true data types, right? So the numeric value stays as a numeric value, the character value stays as a character value, and the logical value stays as a logical value, right? So now I'll go ahead and create another list. So I will name this list to be my list 2. And this time what I'll do is I'll use the list function and I'll pass in 3 vectors inside this list. So I will pass in a numeric vector inside this. So I'll use the C function, and the numeric vector would comprise of these 3 elements 1, 2 and 3. After this will comprise of a character vector, and the character vector would comprise of A, B and C. So let me change this to small b over here. Then I'll pass in the third vector or the third component. So the third component would comprise of logical values, and the logical values are true, false and true. Let me hit enter. Now let me print out this list. So let's see what do we get. So it's my list 2. So this is the list, guys. So this is the first component, this is the second component, and this is the third component, right? So the first component contains a vector of 3 numeric values. The second component contains a character vector of 3 different individual characters. Then we have the third component, which contains a vector of 3 logical values. So now let's understand how can we extract individual elements from this sort of list. So let's say I wanted to extract this element from this entire list. So this element is present at the second location of the second component, right? So first I would have to give in the name of the list, which would be my list 2. After this I will specify the component. So 2 square braces. Inside that I will give in another set of square braces. So now let me specify the component number, which is 2. After this I will give in the element position. So in the second component or from the second component, I would want the element present at index number 2. So I will give in 2 over here. And we have successfully extracted this value. Now similarly, let's say if I wanted to extract this true value from this third component. So this is element number 1 at component 3. So I would have to give in the name of the list, which is my list 2. So I'd have to specify the component number. So the component number is 3. Then I'd have to specify the position where the element is present. So it is present at first position. So from the third component, I am extracting the first element and we get the true value, right? So this is how we can work with lists. Now let's go ahead to the third object, which is a matrix. So matrix is not actually a linear object. It is a 2-dimensional object. So when I say 2-dimensional object, it would have both the rows and the columns. And this matrix would contain only homogeneous elements or elements of similar type. And this is how you can create a matrix. So we can use the matrix function. So this matrix function first takes in the data where all the elements come from. After this, we specify the number of rows present in the matrix. So this is the result for this command over here. So when we specify the number of rows to be 2, we get the number of rows to be 2 over here, right? So this is how a matrix looks like. So we have rows and we have columns, and all of these elements are coming from this data over here. So let's head to our studio and implement a matrix. So let me use the matrix function. I'll type in matrix over here. Then let me pass in the data. So the data which should be present in the matrix should be coming from this vector. And this vector would be comprising of the elements 1, 2, 8. So let me hit enter and let's see what do we get. So this is the matrix which we get. So we have 8 rows and 1 columns. So if we do not specify the number of rows in the matrix, then it automatically assigns each element to a new row. So since we have 8 elements over here, we have 8 rows and 1 single column. So let me go ahead and use the n row parameter to set some predefined number of rows. So let's say I'd want 2 rows in the entire matrix. So the n row value would be 2. Right. So this is our matrix, guys. So we have 2 rows and 4 columns. Now what you see over here is these elements are arranged with respect to column and not with respect to row. That is, so this is 1, 2, 3, 4, 5, 6 and 7, 8. These are arranged with respect to the column. So if I wanted these to be arranged with respect to the row, I have the by row attribute and I will set this by row attribute to be true. So these elements which were actually aligned with respect to the column now have been aligned with respect to the row. So 1, 2, 3, 4 are in one row and 5, 6, 7, 8 are in another row. So I will store this in a new object and name that object to be mat1. Right, now let me print mat1 over here. So this is our matrix. Now let's understand how can we extract individual elements from this matrix. So let's say I wanted to extract this element over here. So this element is present at row number 2 and column number 3. So again, I would have to give in the name of the matrix, which is mat1. Then I will give in the square braces over here. Inside the square braces, I will first specify the row number. So the row number is 2. Then I'll put in a comma. After that, I will specify the column number. So the column number is 3. Let me hit enter. Right, so this is how we have extracted the element or the value 7 from this entire matrix. Right. Now let's say I wanted the element this 5, 7 and 8 from this matrix. So let's do that. So again, I would have to give in the name of the matrix, which is mat1. After that, I will give in 2 square braces and from the second row. So the row number is 2, which I'd give in, and I would require the element which is present at column number 1, 3 and 4. So I will use the combine operator and I will specify the column values which are 1, 3 and 4. Right? So this is how we can extract these individual elements. And similarly, let's say if I wanted to extract this entire row from this matrix. So for that, I would have to type in the name of the matrix, which is mat1. I will use the square braces. So I will give in the row number, which is 1. And since I don't want all of the columns from this row, I'll not assign anything over here. So I'll just leave it to be blank. Right? And voila, we have extracted all of the elements which are part of the first row. Right? So that is how we can work with the matrix. Next, we have an array. So arrays are basically just an extension to a matrix. So matrix was a two-dimensional object. So arrays, since they are an extension to matrix, they have more than 2 dimensions. And the elements which are stored in an array, they are all homogeneous. So this is the syntax to create an array. You use the array function and then you pass in the data values. After that, you set the dimensions. So this, what you see over here, 3, 3, 2. So this basically tells you that we will be getting 2 matrices which would have 3 rows and 3 columns each. Right, so if this seems too confusing to you, let's go to R and let's actually create an array by ourselves. So to create the array, let us first create the vectors which would be passed in as the data elements inside the array. So let me create the first vector. I'll name that first vector to be v1. And the values in this vector would be all of the numbers starting from 1 to 8. Now I will create another vector and name that vector to be v2. And the elements which would be there in this vector are the numbers starting from 9 to 16. Let me hit enter again, right? So let's have a glance. v1 is all the numbers from 1 to 8 and v2 is all the numbers from 9 to 16. Now I can go ahead and create the array. So I will use the array function. Now let me give in the data. So the data is coming from those 2 vectors over here. I will use the C operator to combine those 2 vectors. First vector is v1, second vector is v2. So we have successfully given the data. Now let me set the dimensions. Right. So let's say I would want 2 matrices where I have where I want each matrix to have 2 rows and 4 columns. So I will use C. So I will give in the first value, which would be for the row. So I would want 2 rows, I would want 4 columns, and I would want 2 such matrices. So this is what we get. So this dim value of 242 basically states that I have 2 matrices which are of 2 cross 4 type. So each of these matrices has 2 rows and 4 columns. So let me store this in a new object and name that object to be ARR1. Let me print ARR1 now. Right, so this is our resultant array. Now let's understand how can we extract individual elements from an array. So again, I would have to give in the name of the array, which is ARR1. Then I will give in the square braces, and inside these square braces, let's say I'd want to extract this element over here. So this element is present at second row, second column of the second matrix, right? So these would be the values. So I will give in the row number, which is 2. I would given the column number which is also 2. Then I will given the matrix number which is also 2. Right? So we can extract this element like this. Now let's say I would want to extract this element value 8 from this entire array. So this is present at row number 2, column number 4 and matrix number 1. So let me give in the name of the array which is ARR1. So I will give in the row number which is 2. Then I will give in the column number which is 4. Then I will give in the matrix number which is 1. Right? So we have extracted this element value 8 from this matrix. So this is how we can work with arrays. And then we have something known as a factor. So factors are basically objects which are used to categorize the data. So let's take this example over here. So we have a character vector over here. But in this character vector, we have the same element value repeating twice. So we have male, female, female, male. So we have male repeating twice and female repeating twice. So this basically means that we can convert this into a categorical variable. That is, we can convert this into a categorical variable which would have two categories. The first category would be male and the second category would be female. So this is where the factor objects come in. So what we'll do is we will take this character object. We will put this character object as a parameter, the as.factor function, and then we can convert this into a categorical variable or a factor variable. So let's go to our studio and work with some factors. So now what I'll do is I'll create a vector once. So that vector would comprise of 3 character elements x, y and z, and I will repeat those same values 5 times. And to do that, I would require the REP function which stands for repeat. So inside this repeat function, I am creating a new vector which would comprise of 3 character elements. So the first character element is x, the next character element is y, and the third character element is z. So we have 3 character elements. Now what I'll do is I will be repeating these 3 elements 5 times. So let me hit enter. Right? So what you see is x, y, z is being repeated 5 times. So this is once, twice, thrice, 4 times and 5 times. So now I will store this in a new object and I'll name that object to be my data. Let me check the class of my data. Class of my data. Right, so this is a character. Now since we already know that this character vector has 3 different categories, right? So let me print in my data again, right? So this character vector has 3 categories which are being repeated again and again, and these 3 categories are x, y and z. So now if I wanted to convert this character vector into a categorical variable, all I need to do is use the as.factor function. Inside this as.factor function, I will pass in the my data variable and I will store it back to my data. Now let me have a glance at this class of my data. So this time we see that this is a factor. Right, now let me print my data. Let's see what is the difference, right? So see that these are all of the elements and the elements have been segregated, right? So we have 3 levels, x, y and z. Okay, so this was how we can create factor objects in R. And then finally, we have a data frame. So data frame is basically a 2-dimensional structure where we can have heterogeneous elements. So here, each column can comprise of only homogeneous elements, while a row can either contain homogeneous or heterogeneous elements. So, and this is the command to create a data frame in R. So we will use the data.frame function, and inside this data.frame function, we can create different columns. So here what we are doing with this command is we are creating 2 new columns. So I am naming the first column as name, and the values which would go in the first column are Sam and Bob. The name of the second column is age, and the values which would go into the second column are 32 and 48, right? And this is the resultant data frame which we get. So we have 2 columns. The first column is name, the second column is age, and the values under name are Sam and Bob, and the values under age are 32 and 48, right? So now let's go to R and create a data frame by ourselves. So now what I'll do is I want to create a data frame which would be comprising of two columns. The first column would comprise of names of fruits and the second column would comprise of the cost of those fruits. So I will use in the data.frame function and I will name the first column to be fruit name. Now let me assign values to this first column by using the C function. So let's say I want 3 fruits over here. So the first fruit would be mango, the second fruit would be apple, and the third fruit would be banana. So now we have created the first column. After this, we'll go ahead and create the second column. So the second column would be fruit cost. So let's assign some cost to those 3 fruits. So the first cost value would be, let's say, 105. The second cost value would be 57 and the third cost value would be 80. So now I will store this in a new object and name that object to be fruit. Let me have a glance at fruit now. So we can use the view function to have a glance at a data frame. So view of fruit. Right. So we have successfully created this data frame which would comprise of these two columns. So the first column is the name of the fruit and the second column is the cost of the fruit. The first column comprises these 3 values, mango, apple and banana, and the second column comprises these 3 values, 105, 57 and 80. Right. So now we'll learn how to extract individual columns from this data frame. So let's say I wanted to extract this fruit cost column from this data frame. So for that, I would have to give in the name of the data frame first, which is fruit. After that, I will use in the dollar symbol, and using that dollar symbol, I will select that column which I want to extract. And since I want to extract this fruit cost column, I will select this. So what I'm basically doing is from the fruit data frame using the dollar symbol, I am extracting the fruit cost column. So let me hit enter. Right, so we have successfully extracted this column from this data frame. Now, let's also understand how can we extract individual values from this data frame. So let's say I wanted to extract this value from this data frame. So this value is present at third row, second column. So if I wanted to extract that cell value present at third row, second column, then I'd have to give in the name of the data frame first, which is fruit. I will give in square braces. First, I will give in the row number, which is 3. Then I will give in the column number, which is 2. Let me hit enter. Alright. So we have extracted the cell value from this data frame over here. So these were the different objects with which we could work in R. Now let's head on to decision-making statements. So decision-making statements basically help us to impose a condition, and on the basis of that condition, execute some statements. So in general, we basically work with these two decision-making statements. So we have if and if else. Right. So now let's start with if. So this is how the if statement works. So first, we will give in the condition and check if the condition is true or false. So if the condition is true, then the rest of the statements will be executed, else nothing will be done. Right. So this is how the if syntax works. So we'll give an if over here, we will give in the condition, and if this condition is evaluated to true, only then some sort of action is done, else nothing happens at all. Okay, so let's go to our studio and work with the if statement. Right, so now what I'll do is I will actually create a new vector and name that vector to be check decision. And inside this vector, I will give in 6 numeric values, which would be 10, 20, 30, 40, 50, and 60. Right? So we have our check decision vector ready. Let me hit enter. Right? So we have this vector ready. Now, let me use the if statement to find out if the element present over here, the value of the element present over here is greater than 30 or not. And if the value is greater than 30, I will perform some action. So I will type in if over here. Then I will give in 2 braces. Inside this, let me give in the condition. So the condition would be check decision and I am checking if the element value, this value which is present at index number 3. So if the value present at index number 3 of this check decision vector is greater than 30, then I will print out the element present at index 3 has value greater than 30. Now let me select all of this and let me print. Let's see if we get something or not. So guys, we don't get anything, so we don't get a result. So why is it that you think? So this is because this condition has been evaluated to false, right? So the third element was exactly 30. So let me print check decision over here. So this is the first element, second element, and this is the third element in check decision. So over here, the condition is if this element's value is greater than 30, only then we will print this, else nothing will happen. And since 30 is not greater than 30, nothing is happening over here. Right. So now let me make a small alteration over here. So what I'll do is, I am checking if the element present in the third index, the value is equal to 30. And if the value is equal to 30, I will print the element present at index 3 has value equal to 30. Let me select this command. Let me paste it over here. Right. So this time, this condition is evaluated to true. So the index which is present at 3 has the value 30. And since this is evaluated true, that is why this statement has been executed and we get the result. The element present at index 3 has value equal to 30. So that was the if statement. Now let's look at the if-else statement. So the problem with the if statement was, if this condition was evaluated to false, nothing else was happening. So this is where if-else statement comes in. So here what we do is, we check the condition first, and if that condition is evaluated to true, we do certain set of actions. But if the condition is evaluated to false, we do an alternate set of actions. So we just don't leave it out there, right? If the condition is evaluated to true, we perform first set of actions. If the condition is evaluated to false, we have an alternative set of actions. And this is the syntax for that, right? If condition, this is evaluated to true, then these statements are executed. Else, or in other words, else the condition is false, then the statements below this are executed. Right. So now let's use the if-else statement. So now I'll be working with this same check decision vector. So now this time what I'll do is, I'll be using the if-else clause and I will check if this value is greater than 30. And if this value is greater than 30, I will print value is greater than 30. Else, I will print value is not greater than 30. Right? So it's a very simple thing, guys, right? So I am using the if statement over here, and over here I will be using the vector which is check decision, and I am checking if the element 3 of the check decision vector, the value is greater than 30. And if the value is greater than 30, I will be printing value greater than 30. Else, I will print value not greater than 30, right? So now let me select all of these and let me paste it over here and let's see what is the result. Right. So we get value not greater than 30. So what has happened over here is, so we have checked the condition, this condition evaluated to false. And since this condition evaluated to false, we will come to this else block over here. So this else block is printing value not greater than 30. Right, so these were some decision making statements. Then we have looping statements. So the looping statements basically help us to iterate a certain task, right? So I'm repeating it again. The looping statements, as the name states, they help us to loop a certain set of actions or iterate or repeat a certain set of actions. And the two most commonly used looping statements are for and while. So let's start off with the for looping statement. So this is how this works. So we have the syntax over here, for variable in vector, and then these are the statements which are executed. So what we are basically doing is we will extract the first element from the vector, then we will perform certain set of actions, and then we'll check have we reached the last element or not. So if we haven't reached the last element, we'll go back, we'll extract the next element, we'll perform the same set of actions, and then again we'll check if we have reached the last element. And this process goes on till we have reached the last element, right? So let's go to RStudio and implement a for loop. So this time what I'll do is I'll create another vector and I will name that vector to be check loop, and the values which I'm assigning to check loop would be 100, 200, 300, 400, 500 and 600. So let me print check loop over here, right? So we have a vector ready. So now this time using the for loop, what I'll do is I will be adding 50 additional, so I'll be adding additional 50 values to each of these elements, right? So this 100 will be turned into 150, 200 will be turned into 250, 300 to 350, this to 450, this to 550, and this to 650. So let's do that using the for loop. So I will use for, and we automatically have the snippet over here. So first I need to give in the variable name which would parse through the vector. So let's say I name it to be I, and the vector which I need to iterate through would be check loop. So this I would start from index value 1, and this will iterate through the entire vector. And after iterating, what I'm going to do is I'm going to add a value of extra 50 to each of these elements. So print of I plus 50. So let me explain this properly. So what will happen is for I in check loop. So for I in check loop, initially the value of I would be 100. And since the value of I is 100, I am adding another 50 to this, and the result would be 150. Right. So once this is done, I am going back and I'll check if I've reached the last element or not. No, I've not reached the last element. So the next element is 200. So now I'll take in that 200 and I'll add another 50 to it. So the value would be 250. Next, I'll go back and check if I have reached the last element or not. Again, I have not reached the last element. So this time the next element's value is 300. So this time I'll print 300 plus 50, right? So this is how it'll go on till the last element is encountered. So let me select all of this. Let me print it over here. Right. So this is the result. So initially we had 100, 200, 300, 400, 500 and 600. And those values have been changed to 150, 250, 350, 450, 550 and 650 using the for loop. So this is the assignment. So we'll start off with the select function from the deployer package. So again, we'll have to select the 5th column and the 15th column. Let's do that. So again, this is very simple. We've already seen this, how to select some columns from the data set. So which is a 5th column? 1, 2, 3, 4, 5 dependents. That is a 5th column. So again, first we'll give in the name of the data frame. Then using the pipe operator, we will connect this data set with the select function, and I am extracting only the 5th column and storing it in customer 5. So view of customer 5, right? So this basically gives us the dependents column from this entire data set. Now similarly, we can also extract the 15th column. I'll just let that be because again, that's very simple and it's redundant, right? So after this, we'd have to extract the column numbers 3, 6, 9, 12, 15 and 18 and store it in customer 3 multiple. All right. So again, the name of the data set, the pipe operator, the select function, and inside the select function, I'll give in all of the column numbers which I want to select. So 3, 6, 9, 12, 15 and 18, I'll store it in customer 3 multiple. View of customer 3 multiple, and these are all of the columns that we have just extracted. Right. Now I have to extract all the columns starting from column number 10 to column number 20. So for this, I'd have to just put in a colon over here. So first the name of the data set. So inside select, so it'll be 10 to 20, right? So the first column number, a colon, and then the last column number. So I'll be extracting all the columns starting from column number 10 to column number 20. So C1020 view of C underscore 1020, right? All the columns, and this is what we have. After this, we'd have to extract all the columns which start with the name capital P, right? All the columns which start with capital P. So this is something different. So now inside the select function, we have the starts with attribute. So with the help of the starts with attribute, I can extract a particular pattern. So over here, I'll give in a pattern over here. So I want to extract all those columns which start with the letter P, and I'll store this in customer P view of this, right? So we have extracted all those columns where the column name starts with P. Now similar to starts with, we also have the ends with attribute, and over here we are extracting all those columns which end with S, like this column over here, like this column over here. All right, so we are extracting all those columns which end with S, or the name of the column ends with an S. View of customer, this is S actually. All right, so these are the 5 columns where the column name ends with an S. All right, so these were very simple actually, I believe, just using the select function to select some columns. And then we have the filter function where we can filter out some records on the basis of a condition. So first, we'd have to extract all those customers where the internet service is equal to DSL. Let's do that. So customer churn, pipe operator, and then the filter function, and the condition is internet service is equal to DSL, and I'll store it in customer underscore DSL. View of customer underscore DSL. So let me have a glance at the internet service, right? So we have only those records where the internet service is equal to DSL. So there are 2,421 customers whose internet service is DSL. All right. So after this, we'd have to extract those customers where the contract type is month to month and store it in customer month. Let's do that. So this time the condition is contract is double equal to month to month. That's it, as simple as that. So this is a contract column. So over here, basically we have 3 values, month to month, 1 year and 2 year. And we are supposed to extract only those columns where the contract is equal to month, and we'll store it in customer month, view of customer month, contract column, where is it, right? So there are 3,875 customers whose contract type is of month to month. Right. And then the next question, we are supposed to extract all male senior citizens whose payment method is electronic check and store the result in senior male electronic. So over here, the first condition is gender needs to be equal to male. The second condition is senior citizen value needs to be equal to 1. And the third condition, payment method needs to be equal to electronic check. So let's do that. First, we'll give in the name of the data frame, the pipe operator, and then inside the filter function, we have to give in the 3 conditions. So the first condition is gender needs to be equal to male.
The second condition is senior citizen needs to be equal to 1. And then the third condition is payment method is equal to electronic check. So basically we are extracting all male senior citizens whose payment method is equal to electronic check. And I'll store it in senior male electronic. So view of senior male electronic. So there are 298 senior male citizens whose payment method is electronic check. So any doubt with respect to this command over here? So basically we have given three conditions inside this filter function. Any doubts still here? No? Great. Okay. So after this, we'd have to extract those customers where the tenure is greater than 70 months or their total charges is greater than $8,000. So till now we have used the AND operator. Over here we'll be using the OR operator. So this time the first condition is tenure needs to be greater than 70 or total charges needs to be greater than 8,000. And we'll store this in customer total tenure. View of customer total tenure. Right. So let's have a glance at tenure. So we see that the tenure is greater than 70. Let's have a glance at total charges, right? So now, even though over here the total charges is not greater than 8,000. So let's actually take, right? So this first cell value over here, even though the total charges is not greater than 8,000, but the tenure is greater than 70. That is why we have this a record over here. Similarly, even though the total charges is not greater than 8,000, but still again the tenure is greater than 70, so that's why we have this record. So it's OR operator. So either this condition has to be true or this condition has to be true, right? So let's head on to the final question on the filter function. So now we have to extract those customers whose contract is of 2 years, payment method is mail check, and the value of churn is equal to yes. Let's do that. So again, three conditions. First condition is the contract needs to be of 2 years. The second condition, payment method is equal to mail check, and third condition, churn is equal to yes, and we'll store this in 2 mail years. View of 2 mail yes. So this is quite interesting, right? So we have just 3 records or 3 customers where the contract is equal to 2 years, the payment method is equal to mail check, and the churn is equal to yes. Or in other words, there are only 3 customers whose contract is of 2 years, payment method is mail check, and will be churning out to another network. So this was all about the filter function. Right, so let's head on to the next function of the deployer package, which would be sample in, sample frac, and count. So we are supposed to extract 333 random records from the customer churn data frame. Let's do that. Right. So we given the name of the data frame, which is customer churn, and then the sample n function. Basically, again, so this is basically an analogous to the sample function from the base R. So sample n is a part of deployer. So you can consider this to be analogous to the sample function from base R, right? So we want 333 random records from the entire customer churn data set, and I'm storing that into customer 333. View of customer 333. So these are the 333 random records. Similarly, if I want 1000 random records from the entire data frame, I just have to give in 1000 inside this. View of customer 1000. So these are the 1000 random records which I have. Now, so after sample n, we have the sample frac function, which helps us to select a random percentage of records from the entire data set. So over here we are extracting 23% of the total records randomly, right? So we'd have to give in a fractional value 0.23. So this 0.23 basically means that we are randomly, can we sample random samples from the first? Okay, so for that you would have to, so I don't think that is possible with the sample n function for this. That wouldn't be possible with the sample n function. All right. So first you would actually have to maybe select the first. Okay, so you'd have to do two steps for this. First would be customer churn. I want all the columns and I want the first 1,000 records. So I will store this in customer 1,000. Now out of this, I want a random sampling of 333. Right? So you'd have to do this in two steps basically. Sample n and then 333. So I'll just do this in 3 view of 3. Right? So you would basically have to do this in two steps. So the first step, you'd have to extract the first 1,000 records manually, and then you'd have to do the random sampling. Right, so we were working with the, sorry for that. Yeah, so as I was saying, we were working with the sample frac function and this. So I'll just bring some water and come guys, just give me 2 minutes. Right. So we are extracting 23% of the records from this entire data set. View of customer 23%. So basically 23% of 7,043 comes down to around 1620. So this is random sampling of 23% of the records from the entire customer churn data set. Right, so after this we have the summarize and group by functions. So we will basically not do the first two because again this is like this doesn't mean anything. So we'll do the third, fourth, and fifth. So we'd have to find out the standard deviation of tenure and group it with respect to payment method. Let's do that. So what we are doing is we want to know the standard distribution, the standard deviation of tenure with respect to the different categories of the payment method. So I want to know the standard deviation of tenure with respect to electronic check, the standard deviation of tenure with respect to credit card, standard deviation of tenure with respect to mail check, and so on. So again, first I'll give the name of the data frame and then I will give in the group by function. So first I will group it with respect to the payment method column. So after I group it, then I will summarize. So inside the summarize function, I'll give in the standard deviation of the tenure. So this is what we get. So the standard deviation with respect to bank transfer is 23 months, with respect to credit card as 23.3, with respect to electronic check as 22.4, and with respect to mail check as 21.2. Right. Now you guys need to keep in mind that the sequence should be first the group by function and then the summarize function. So if you interchange these two, then this will not work. So let's say I will do Control X over here and then Control V over here. So now this won't work because we are giving the name of the column later on, right? So this is why this will not work over here. So basically first you would have to group and then you would have to use the summarize function. So this is how basically you can use the group by and summarize functions together. Now, after that, we'd have to find the median of monthly charges with respect to the contract column. Let's also do that. So whereas the contract column, right? So we want the median of this monthly charges with respect to 1 year, with respect to month, and with respect to 2 years. So again, first we'll give the name of the data frame, and then we'll give the group by function, and then we are grouping it with respect to the contract column. After that, inside the summarize function, we will so we basically want to summarize the median of the monthly charges. Right. So the median monthly charges of those customers whose contract is month to month is around $73. Of those customers whose contract is 1 year, it's around $68. Of those customers whose contract is 2 years, it's around $64. And then finally, we want the variance of total charges with respect to internet service. Let's do that. All right. So I want the variance of monthly charges over here with respect to internet service. Was it? No, so that was variance of total charges with respect to internet service. So let me just change it to total charges over here. And then I need to group it with respect to internet service. All right. So now over here we have NA values because there are already some NA values present in the total charges column. So let's go ahead and remove those NA values. So over here, I just have to put NA.RM equals true. When I do this, those NA values are removed and I get the total charges for DSL, for fiber optic, and when the customer doesn't even have internet service. So this was working with summarize and group by. All right, any doubts till now? Right. So then we are also done with data manipulation. Now it's time to start with data visualization. So we'd have to make bar plots. So the first bar plot is for the phone service column. So let's create a bar plot for the phone service column. Where do we have phone service? Right. So we'd have to create a bar plot for this. And now, so basically bar plots, as you might already know, they are used to understand the distribution of categorical values. So this is how we can create a bar plot. So we'll use the ggplot function, and first we will start off with the data layer. So first the data is customer churn, and then we'll add the aesthetic layer. So we are mapping the phone service column onto the X aesthetic. Now after we're done with the data layer and the aesthetic layer, we will go ahead to the geometry, which is bar plot. So to make bar plots, we will use the geom bar function. Oh, I actually have to load the package first, library of ggplot2. Only then I can use the ggplot function. Right, so this is the distribution of the phone service column. So we see that majority of the customers, over 6,000 of the customers have phone service. There are like very few customers, like less than 1,000 customers who don't have phone service. So this is the inference which we can draw from this bar plot over here. So now after creating the bar plot, we were also supposed to add a fill color and a boundary color. Let's do that. So now inside the geom bar, I'll just use the fill aesthetic and set the fill aesthetic to be equal to pink. So this is how we can assign a fill color. Now after assigning the fill color, we were also supposed to add a boundary color. So we can add a boundary color by using the COL aesthetic, and that was supposed to be Peru, right? So we have added a fill color as well as a boundary color to this. Then we are supposed to make a bar plot for the internet service column. Let's do that. So again, data layer customer churn, and then we map the internet service onto the X aesthetic, and then we make a bar plot for this. So this is the distribution of the internet service column. So we see that there are more than 3,000 customers whose internet service is of type fiber optic. There are around, let's say, close to 2,400, maybe 2,400 customers whose internet service is DSL. And then there would be around 1,500 odd customers who don't avail internet service. So after this, we were supposed to assign the contract column onto the fill aesthetic. Let's do that. Right, so now basically we are not using fill as an attribute, we are using it as an aesthetic. So if you want to use fill as an attribute, we will give this inside geom bar. But if you want to use this as an aesthetic, we will give this inside the aesthetic layer. So basically we are mapping internet service onto the fill aesthetic. So the fill color of these bars would be determined. Oh, so it was actually supposed to be determined by the contract column. So let me change it to be contract. All right, so the fill color should have to be determined by the contract column. So this is how a plot will look. So over here, this pink color is for those customers whose contract is of type month to month. This green color is for those customers whose contract type is of 1 year. And this blue color is for those customers whose contract is of type 2 year. So if we take this first category where the internet service is DSL, then we see that the major proportion is of those customers whose contract is month to month. Similarly, again, those whose internet service is fiber optic, again for them, the contract is majorly month to month. Now, if we take the third case where people don't even avail internet service, then most probably their contract would be of 2 years, right? So there is a greater probability for those customers who don't avail internet service. So their major probability, so their contract for them, the major probability is to be of 2 years. Right. So after this, we were supposed to set the position of the bars to identity. Let's see what is the difference over here.
Actually, I have a question.
Yeah, sure.
What is the count on y-axis?
Mm-hmm.
What is the count on y-axis?
Count as the number of customers over there.
But in the data set, I think more than 7,000 customers. So why is showing only 3,000?
Because this is the range we have over here. Out of the 7,000, there are 3,000 odd whose internet service is fiber optic. There are 2,000 odd whose internet service is DSL, and there are 1,500 odd who don't even avail internet service. So like add this up, 3,000 plus
Yeah, got it.
2,500 plus 1,500. So that comes down to 7,000 odd.
Okay, I got it. Okay.
Right. Okay, identity is this. Seems like this is not changing to anything. Okay, great. So, and finally, we are supposed to make a final bar plot for the tech support column. Let's do that. Again, data is customer churn. We are mapping tech support onto the X aesthetic and the geometry is geom bar. So this time, the number of customers who don't avail tech support is very high. So there are around 3,500 customers who don't avail tech support. And these are those customers who just don't even have internet service. So there are 1,500 customers who don't even have internet service. And this value is basically for those customers who have internet service and also avail tech support. So there are around 2,000 customers who have internet service and avail tech support. So this is how we can draw inferences from this bar plot. After that, we were supposed to assign churn onto the fill aesthetic. Let's also do that. So this time the pink color that denotes those customers who will not churn out, and the blue color denotes those customers who will be churning out. So if we take this category DSL, then the proportion of customers who will be not churning out is high. So it is actually the same case for all three bars, right? So the proportion of those customers who will not be churning out is high in these three cases. Right. So that was how to make bar plots, right? So are you clear with making bar plots and adding colors to them, assigning different columns onto the fill aesthetic? Any doubts with respect to this?
No.
Okay. Right, so bar plot, we're done. And then we have to make histogram. So we have to make a histogram for the tenure column. And then we'll have to add the fill color, the boundary color, and change the number of pins. Let's do that. So again, the data is this, and we are mapping tenure onto the X aesthetic. So this time the geometry is histogram. So if we have to make a histogram, we have to use the geom histogram function. And this is the distribution of the tenure column. So if we want to get the distribution of a continuous variable, then we'll go ahead and make histograms. Right, so this you'll have to understand the difference between bar plots and histograms. So bar plots you'll use when you want to understand the distribution of categorical columns, and histograms you'll use when you want to understand the distribution of continuous columns. So this basically states that there are around like 600 odd customers whose tenure is like not even 1 month. They churn out before 1 month. So there is a very high proportion for this. And then again, there is again a high proportion. So there are around like 500 or 550 odd customers whose tenure is around 70 months or something. And if we take this one, So there are around 200 odd customers whose tenure will be around 42 months. So let's take this case. So there would be around 310 odd customers whose tenure would be 10 months. After that, we were supposed to assign a fill color. So we are using fill as an attribute, not as an aesthetic. So that is why we'll use this inside the geom histogram function. And the fill color which we are assigning is medium spring green, right? So this color which you see over here, this is medium spring green. After this, we are also assigning a boundary color by using the COL attribute, and the boundary color is azure. So this is azure. And then finally, we will go ahead and change the number of bins. So this warning which you see, using bins is equal to 30, pick better value with bin width, right? So by default, it just gives us 30 bins. So if you want to change the number of bins, then we can use the bins attribute. So this time I am setting the number of bins to be equal to 100. So when I set the number of bins to be equal to 100, this is what I get. Okay, so this was how we can create histogram for the tenure column. Now, similarly, we'll go ahead and create a histogram for the monthly charges column. So again, data is customer churn. We are mapping monthly charges onto the X aesthetic, and the geometry which we are using is geom histogram. So this is the distribution of the monthly charges. So there is again a very high proportion over here. So this tells us that around 1100 customers whose monthly charges is around $25, right? So this is the greatest the range. So there are very high customers whose monthly charges is very, very less. So there are 1100 customers whose monthly charges is just around $25. And if we take this case, so there are very few customers, so there would be around maybe 280 or 280 odd customers whose monthly charges are actually greater than 100, and there would be like exactly 300 customers whose monthly charges are $100. So again, if we take this peak, so like close to around 300 customers whose monthly charges would be around maybe 55 or 60 over here. So this is how you can draw inferences from this histogram. Now after this, we are supposed to map the payment method onto the fill aesthetic. Right, so over here, what we've done is we have mapped the payment method onto the fill aesthetic. So this pink color denotes bank transfer, green color denotes credit card, blue color denotes electronic check, and this dark pink or purple, whatever color you call this basically represents the mail check. So again, there is like no purpose to add this color, so this just brings in more chaos. But then again, later we'll see that we have something known as a facet grid. So using facet grid, we can separate each of these categories into separate facets. So that is when the visualization would be even better. All right. Now, after this, what are we doing? So we are setting the position to be equal to identity. Right. So the difference between this and this is basically, it. So whatever. So let's take this case over here. So the bank transfer. So this bank transfer is the like absolute value of this, right? So the absolute value of bank transfer would be from this to this. So this will be around 200 odd. And this is again the absolute value of credit card, which is around maybe, how much is this? Again, 200 odd. So now what we'll do is we will be basically stacking the absolute values on top of each other, and we'll get only those values. So over here, mailed check has the maximum count. The other values basically go behind this. So the other bins which you saw in the earlier graph, electronic check, credit check, and bank transfer, those bins have been basically stacked behind this, this mail check. So identity basically is, it shows you the true identity. The other values or the other categories go behind this original histogram. So this basically helps you to understand the proportion of those bins which have the maximum values over here. So let's see over here, let's say if the monthly charges is somewhere around $25, then most probably their payment method is mail check. Similarly, if you take this group over here, so this group, if the monthly charges is somewhere between $75 to $100, then the major proportion of customers, their payment method is electronic check. So this is the sort of inference which you can draw from this. Now, similarly, let me also map the online backup column onto the fill aesthetic, right? So this is what we get over here. Again, these are the absolute values. So let's say if I set the position to be equal to identity over here. So this is the difference. So this is the absolute values. This is when the position is equal to identity, right? So this time, if the monthly charges are around $25, then most probably they don't even have internet service. And if their monthly charges vary from $75 to $100, then they will have internet service and they will also be availing online backup. And similarly, if you take this, so this would be somewhere between $70 and $75. So if it's $70 and $75, then most of the customers have internet service, but they are not availing online backup. Right. So any doubts still here on how we are using this identity position, the difference between this and the previous plot? Okay. So we'll just make the final histogram then. So we'd have to make a histogram for the total charges column. Let's also do that. Control C and then ES. Okay, right. Right. So x-axis, we are mapping the total charges, and I'll actually delete this first and then add it later. Right. So this is the distribution of the total charges column. So we see that the majority of the customers, their total charges is somewhere around, how much would this be? So this will be 1250. So this will be somewhere around $500 maybe, right? So there are very, very few customers. So let's take this. So there would be around 125 odd customers whose total charges are around $5,000. Again, there would be around, let's say, 50 odd customers whose total charges would be greater than $7,500. Now let's also map the gender column onto the fill aesthetic. So fill should be equal to gender. Right. So over here, this pink corresponds to all of the female customers. This blue corresponds to all of the male customers. Right. Again, let me set this to be identity over here. So what this basically means is there is just a greater proportion of male customers in our data set than female customers. We have this totally blue because, again, there is a greater proportion of male customers in our data set than female customers. All right. Now let me map the internet service column onto the fill aesthetic. All right. So we see that we have three colors actually. So let me remove identity first. So we have three colors. Blue is for those customers who don't even have internet service. Green is for those customers who have internet service and their internet service is fiber optic. And pink is for those customers who have internet service and their internet service is equal to DSL. So again, the people who don't have internet service, so their maximum total charges would come to around maybe $1,800 or somewhere like that, right? And there is a greater proportion of those customers who avail either internet service of DSL or fiber optic, right? So this was all about histograms. Now we'll go ahead and make some scatter plots. So we'd have to make a scatter plot between total charges and tenure and map total charges onto the y-axis and tenure onto the x-axis. Let's do that. So till now, we did, so we had just one column mapped onto the x-axis. So in scatter plot, we'll have one column mapped onto the x-axis and one column mapped onto the y-axis. So this over here is basically total charges versus tenure. Total charges is mapped onto the y-axis and tenure is mapped onto the x-axis. So this is the aesthetic layer. And then if we have to make a scatter plot, we will use the geom point function. So this is basically the distribution with respect to tenure and total charges. So you see that as the tenure of the customer increases, the total charges of the customer would also increase. Now after this, we are supposed to assign color to this. So I am assigning a color of wheat 3 to these points over here. Right, so this color which you see, that is equal to wheat 3. Now I am using COL as an aesthetic, not as an attribute, and I am mapping the payment method column onto the COL aesthetic. I'll hit enter. All right, so again, so this is like very chaotic over here. So we pretty much don't really understand what this is. So again, to make better sense of it, we will have to facet this data with respect to different payment methods. Now I will map the gender column onto the color aesthetic. So again, this really doesn't make sense. We'll have to facet the data. All right. So that was basically between that total charges and tenure. After that, we'd have to make a scatter plot between tenure and monthly charges. Let's also do that. So we are mapping tenure onto the y-axis and monthly charges onto the x-axis, and the geometry is geom point. Now this scatter plot basically tells us that there is no proper relation between monthly charges and tenure. So we basically can't say that if monthly charges increases, tenure also increases, or if tenure decreases, the monthly charges increases. So we can't say if there is any sort of relationship between these two variables. Now, just for fun, let's also add some color to this. So we'll add yellow green to this. I'm using COL as an aesthetic. Sorry, I'm using COL as an attribute, and I'm assigning the color of yellow green. So this color which you see, this is yellow green. After this, I'll map the internet service column onto the COL aesthetic. So this time I am using COL as an aesthetic, and I'm mapping internet service onto the COL aesthetic. Now, when we map the internet service onto the COL aesthetic, so we basically get a sort of a bifurcation. So with this, we understand that. So this blue color is for those customers who don't have internet service. This pink color is for those customers whose internet service is DSL, and this green color is for those customers whose internet service is fiber optic. Now, the inference which we can draw from this is those customers whose monthly charges is like $25 or less than $25, their internet, so they basically don't even have internet service. After that, those customers whose monthly charges are between, let's say, $25 to around $70, then their internet service would be equal to DSL. Similarly, those customers whose those customers whose monthly charges is between $75 and $100, then most probably they would be availing the fiber optic internet service. All right. And then I'll also map the contract column onto the COL aesthetic. And let's see, what do we get? Well, this is not much clearer as compared to the previous plot, isn't it? Right, so again, we'll have to visit this to understand this better. So this was scatter plot. So any doubts with respect to scatter plot? So basically we have mapped one column onto the y-axis and one column onto the x-axis, and we've used the geom point function to make all of these scatter plots. Right, so then we have box plots, and this time we have to make a box plot between tenure and partner column. Right, so now box plots are used where we have to understand the distribution between a categorical column and a numerical column, or basically a continuous variable and a categorical variable. So over here I am mapping tenure onto the y-axis and partner onto the x-axis. So over here, tenure is my continuous variable and partner is my categorical variable. So this were the aesthetics. So the geometry which I'm using is geom box plot. So geom box plot would basically help me to create some box plots. All right. So this is our box plot. So what we understand is the median value of the tenure is greater for those customers who have a partner, right? So the median value of those customers, so this is for those customers who have a partner. So seems like if the customer has a partner, their tenure value, their median tenure value is somewhere around 50 months. On the other hand, if the customer does not have a partner, then most probably his median tenure value is not even 20 months, right? So this is basically how we can draw inferences from box plots, right? So we'll basically compare the median values. So over here, the median value, if the customer has a partner, then seems like his tenure would be longer. And similarly, if the customer doesn't have a partner, then seems like his tenure will be shorter. So again, after this, let's also add some color to this. So we'll use the fill aesthetic we'll use the fill as an attribute, and we'll map violet to these box plots. So this is violet. Now after this, I'll also add a boundary color, which will be snow 3, right? So this is the boundary color. After that, we'd have to make a second box plot where we have tenure and multiple lines. So tenure is onto the y-axis and multiple lines is onto the x-axis. Let's do that. So this is our box plot. So this time we see that if the customer has multiple lines, then he would have the maximum medium tenure value, right? So if the customer has multiple lines, then his median tenure value would be around 45 months, most probably. And if the customer has, so the customer doesn't even have internet service, then his median tenure value would be somewhere around 30 months. So this is for those customers. So they have multiple lines. They have phone service, but they do not have multiple lines. In that case, their tenure would be somewhere around 18 months or so. Now what we'll do is we'll go ahead and map the partner column onto the fill aesthetic. So this time we basically get 2 box plots for each of these corresponding categories, right? So this pink color denotes those customers who don't have a partner, and blue color denotes those customers who have a partner. So as we saw in the earlier case, those customers who have a partner seems like their tenure value is higher than those customers who don't have a partner, right? So each of these three categories, so let's take this category. So this is for again those customers who have phone service but do not have multiple lines. So seems like the median tenure value is like very high compared to this. Again, median tenure value very high, median tenure value compared to this very high. Right, and then what do we
Hello.
have? Yeah.
What is the dots on the first box plot?
Uh-huh.
There is multiple dot on first box.
So those are basically the outliers, right? So normally when the customer does not have multiple lines, so basically his median tenure value would be somewhere between 1 month to around 25 months. So this is an aberration actually. So maybe there are 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 customers whose tenure value is basically an aberration. So normally the customer's value would lie somewhere in this range. So these are basically outliers over here.
Okay, thanks.
Right. Then we are supposed to make a box plot between tenure and contract. Let's do that. So this time tenure is onto the y-axis and contract is onto the x-axis. So again, so these outliers, we have outliers over here, we have outliers over here, right? So let's start with this. So normally if the person's contract is on a 2-year basis, then his median tenure would be greater than 60 months, right? His median tenure is greater than 60 months, and normally the tenure would be somewhere between 70 months to around 50 odd months, right? 50 months to 70 odd months. So these values which you see, these are outliers. So maybe around 10 odd customers who basically 10 odd customers whose tenure is less than maybe 15 odd months, right? These are again outliers. Again, in this case, so what we see is these are totally contrasting values. So if the person has a 2-year contract, then his tenure will be quite high. On the other hand, if the person has a month-to-month contract, then we see that his tenure is quite low over here. So if it is a month-to-month contract, then his median tenure would be somewhere around 12 months or so. So these are again outliers. So there are like only 4 customers whose tenure is greater than 70 months and their contract is month to month. And for this case, so this is like 1 year. So those customers whose contract is 1 year, their median tenure would be somewhere around 40 months. Now let's map the internet service onto the fill aesthetic. So now what we get is 3 different box plots for the corresponding different internet service, right? So maybe you can have a look at this graph and draw inferences by yourself. Right. So we are also done with box plot, and then we will go ahead and facet our data. Right. So faceting again, so it basically whenever our graph is very chaotic, there are too many data points, there are too many columns mapped onto the same graph, we can use a facet grid to facet all of those data into different groups. So that is basically when we use a facet grid. So over here first we are supposed to build a box plot between tenure and multiple lines, and then map the internet service to the fill aesthetic. So let's do that first. So this is our plot over here. Now we see that again, so drawing inferences might be a bit difficult from this. So this is where we will go ahead and facet the data with respect to the internet service column over here, right? So for that, we will have to use the facet grid function, and first we'll give the tilde symbol, and after the tilde symbol, we will give in that particular column on the basis of which we are supposed to facet the data, right? So this was our original plot after faceting our data. So we have basically faceted the data on the basis of the internet service. So this is one group for the those customers whose internet service is DSL. This is one group for those customers whose internet service is fiber optic. And again, this is one group for those customers whose internet service who don't even have internet service, right? So now drawing inferences from this is much easier than the previous plot. So we see that if we take these two cases, so if the internet service is either fiber optic, or if the customer doesn't even use internet service, so they, so there is like 100% likelihood that they don't have a phone service, right? Now, all those customers who don't even have phone service, then all of those customers would belong to this category. So all of those customers would basically have the internet service DSL. Right. So this was the first part in fisting our data. After that, we will go ahead and create a scatter plot between total charges and tenure. Let's do that. And we are also mapping the contract column onto the color aesthetic. So again, drawing inferences from this is a bit chaotic. So what I'll do is I will facet this data on the basis of the contract column. So first I'll give the tilde symbol, and then I'll facet this data on the basis of this contract column. Right, so this time I have three different facets. First facet is for those customers whose contract is month to month. Second facet is for those customers whose contract is 1 year. And third facet is for those customers whose contract is of 3 years. So again, this is basically much easier to either show it to other people and also to draw inferences from this. Similarly, again, the third was we have to build a histogram for just monthly charges, and then we have to map payment method onto the fill aesthetic. Right, this is done. Again, this is very, very chaotic. So we can facet this into different groups. Right. So now again, this is much more prettier than the previous plot. So we have different facets with respect to each of the different columns. So this is why we basically use faceting to make our graphs more pleasing to witness. So this was all about yeah.
Can we add bins to the same bar plot?
You can. So first you'd have to set this over here. Right. So inside this, I will set the number of bins to be equal to 100. Right. So we've changed this. So basically the number of bins, you'd have to set this inside this function over here, geom histogram. Now let's say I change this to maybe 1000. Let's see how it looks. Right, so this is how our graph will look when we set the number of bins to be 1000. So is that clear?
Yes.
Great. So this is how we can facet the data, and then finally we'll work with the theme layer. So the theme layer helps us to add themes, as the name basically states it. So first we will go ahead and create a bar plot for the gender column. Right. So what I'm doing is I'm creating a bar plot for the gender column. Now, after this, I have something known as the theme layer, right? So till here, the syntax is the same. Now, after this, I will add the theme layer on top of this. So inside this theme layer, with the help of this theme layer, I can add a color to this panel. So this, what you see, this is the panel onto which we draw our graphs. So with the help of the panel, we can add a color to this panel, and also this white background which you see, that is known as the entire plot. So with the help of the theme layer, we can add a color to the panel, and we can also add a color to the entire plot. So we will use the panel dot background attribute and set a color to this. So we will just type in panel dot background, and then we have the element rect function. So if we want to modify any of the rectangular objects in the theme, so this plot is a theme. So this plot is a rectangular object. This panel is a rectangular object, right? So if we want to modify any of the rectangular objects, then we will use the element rect function, and we will set it a fill color, which is chartreuse 4. So we have successfully mapped a fill color to the panel over here, right? Till now, whatever graphs we saw, we were just creating the graphs, but then again, we were not adding themes to the panel and the plot, right? So with the help of the theme layer, we have added a color to the panel. Now, similarly, we can also add a color to the plot, to the whole plot. So till here again, the command is same. After that, I'll add another theme layer. And inside that theme layer, I'll add a background color to the entire plot. And the color for that would be corn silk 4, right? So I've also added a color to the background plot. So this is how we can add color to the panel and also to the background. All right, so any doubts over here on how we're using the theme layer? All right, so first we have to use this theme function. Yeah, go ahead.
These colors, where do we get, how do we get to know like what are the colors? Because this is not a RGB color or not a, so
Right.
these names are something specific to this ggplot or?
No,
or
so we have the colors, we have the colors function. So just use this command over here and you'll see all of the different colors which are available in R. So I'll just copy this command and paste it over here in the chat. Right. So use this command to have a glance at all of the available colors.
Okay.
Right.
Thank you.
Yeah. So after this, we are supposed to make a scatter plot between tenure and monthly charges, and add a title, give a color to the panel, give a color to the plot, and then center align the title. Okay, great. Let's do that. So we are creating a scatter plot between tenure and monthly charges. This is our base plot over here. Now, after creating the base plot, we have the labs function. So with the help of this labs function, I can assign a title, right? So inside this, I will use the title attribute and assign this a title. So the title for this would be tenure versus monthly charges. So this was the initial plot. After that, we have used the labs function on top of this and added a title to this. Now, after adding the title, we will go ahead and add a color to the panel. So again, we'll use the theme function, and inside that, we'll use the panel dot background attribute and set the fill color to be coral 2. Right? So this color which you see, this is coral 2. Again, after this, we will also add a color to the plot. So till here, it's the same function. After that, we'll also add another theme layer. This time we will use the plot dot background attribute, and assign this a fill color of beige. So this becomes a final plot, right? So this is our scatter plot. This is the color of the panel. This is the color of the plot. And then we were also supposed to center align the title. So till now, whatever we've used, it's element rect, right? So we were supposed to make changes to rectangles. That is why we've used element rect. Now we are supposed to make changes to text. So if we are supposed to make changes to text, then theme layer has a function known as element text. And inside this, we will adjust this. So this is where we can use the hedge just attribute and center align this. So when we give this a value of 0.5, this will be center aligned, and we will also assign this a color of red. And this is our final plot. So initially, this is what we had. After that, we center align this and also gave this title a color of red. Right, so we will follow this on adding the different theme layers on top of this. So ggplot2, the best part of ggplot2, why it is widely used in the industry is you can keep on stacking the layers one on top of the other, right? So like you see over here, this is the initial plot. So we just had the data layer and the aesthetic layer. On top of that, we added the geometry layer. On top of that, we added the labels layer. On top of that, we added another theme layer. And again, we added another theme layer, two more theme layers on top of that, right? So this is basically the advantage of ggplot. You can keep on stacking layers one on top of the other. Right.
So this brings us to the end of this session, and do stay tuned to Intellipaat's YouTube channel for more such informative videos.